All right, let's start talking about then how we're going to parallelize this GA. And so this is what we're going to call an island model genetic algorithm. Okay, and so in this situation, we're going to have our master process, which will be at the root, process 0. And then we'll have a series of sub-processes, and I'll write this out as if I'm using 8 total processors. All right, and so the master is going to be what sort of collects all of my command line arguments. So we saw that a couple videos ago of the different pieces that were provided, population size, number of generations, chi, mu, k, and a random number generator seed. Okay, so the master process is the one that collects all that. Then, to start things off, the master process sends all that stuff, those command line arguments, to every subprocessor. Okay, so I won't bother to draw all 8 of those lines, but that's how everything gets kicked off. Okay, so that goes to all the subprocessors. And then each subprocessor is going to run its own genetic algorithm. So every one of these then uses those parameters to set up and execute its own genetic algorithm. And so this would be more or less that code that is provided for you in the uniprocessor situation. Okay? So each one of these is running its own genetic algorithm, largely like the code that's provided. Now, the only difference is that every so often, they're going to do a migration. Okay, so the island model, the island part indicates that each of these is a population evolving on its own island, right? And so you might imagine like Darwin's finches, where different finches on different islands evolved slightly differently. Same idea here, okay? Now, for this to happen, though, we do have to make sure that each of these uses a different random number generator seed. And so a good technique to do for that is to take the seed that's provided and just add your rank, your processor rank, to it. And so that way everyone will start with a different random number generator seed. And so they will all be doing something different, right? If they all started with the same seed, then they would all be doing exactly the same thing, and it would defeat the purpose because you wouldn't be getting anything different. Okay, and then the other thing that's different is every so often, maybe via another parameter here, that we pass in, the interval that is the parameter. Every so often, we will send our best and worst individual to our neighbor. Okay, so processor 1 will send its best and worst to processor 2. Likewise, processor 2 will send the best and worst to processor 3, and so on. Okay, and so now what we've got is we've got these populations that most of the time excuse me, are evolving separately, but on occasion we have some immigration. And the processor 7 here, the one at the end, would wrap around, so it would send its best and worst back to processor 1. Okay, so again, that happens every so often, like maybe every 100 generations, every 200 generations, whatever, some number. You send the best and worst. And so that way now sort of shakes up each population because someone with a different genetic stock, so to speak, is arriving on our shores and then incorporated into that population. Okay. Then at the end of the whole system, each subprocess sends back its best individual. Okay. So there would be 7 of these messages coming back at the end. The master has to collect those. And then at the end, after it's done that, the master looks and finds the overall best and reports that out. So that's how an island model genetic algorithm is going to work. In my next video, I'll demonstrate a working version of this on Onyx, and that should get us started.